Alright class, so last time we started talking about compounds and naming, and we started talking about ionic compounds and how to name them and how to write them. And I want you to remember the basics, right? How do you know if you have an ionic compound? You know you have an ionic compound when you have a metal and you have a non-metal. And we said that's a really good relationship going on there, because what metals want to do, metals want to lose electron, right? Metals want to lose electron, so they become cations, and non-metals, they want to gain electron, so they become anion. So what ionic compound is a balance of charges. And that's really key when we talk about ionic compound. Metal wants to lose electron, non-metal wants to gain electron. So, and the other thing we said all these elements on a periodic table, they are neutral, but when they form a compound, when they form an ionic compound, they would have to lose or gain electron in order to be part of the compound, right? So if you want to form a compound, you have to compromise. Something's got to give. Now, the other thing we said you need to label the periodic table. Group 1A is +1, they always lose 1. Group 2A, they always lose 2. And the reason that they want to lose 1 and they want to lose 2, because they want to look like a noble gas. And that's considered pretty sexy thing to do, to lose electrons to look like a noble gas. Noble gases are the good looking ones on a periodic table. Then we said this was +3, and then for non-metals, they're going to gain -1, -2, and -3. And the reason again, these, if they gain one more electron, they will look like a noble gas. If they gain 2 electrons, they're going to look like a noble gas. So go back to that lecture, make sure you understand that. That was kind of a summary of what we talked about. And what we left off with, we went over writing the ionic compound, naming the ionic compound, and we said we are going to ignore transition metals because they're a hot mess. But today, we are going to actually go over the transition metal and talk about how to write ionic compounds using a transition metal. Now, before I move on, there was one more thing we talked about. We said for tin and lead, they could be +2 or they could be +4. So all of the other elements that we talked about, they only had one possible charge, but tin and lead, they could be +2 or they could be +4. And because of that, we always use Roman numeral, so you can mention which tin and lead we're talking about. Alright, so now, the next thing we're going to talk about now, let's go over these transition metals. The reason I didn't talk about the transition metals last time is because they're a hot mess. There are 2 transition metals, zinc and silver, who have a fixed charge. They only have one charge. So zinc is always +2 and silver is always +1. The rest of the transition metals, they have many possible charges. For example, chromium could be +2, chromium could be +3, chromium could be +4. Gold could be +1, gold could be +3. So minus zinc and silver that have one fixed charge, the rest of the transition metals, they have many different charges. Now, because they have many different charges, what do we use? What do we use when we're naming them? When we're naming those, we use Roman numeral. Remember what we talked about? We said we use Roman numeral when an atom has more than one possible charge. If an element has more than one possible charge, you have to use Roman numeral, because if you tell me gold, I'm going to ask you, well, which gold are you talking about? So you have to say gold 1 or gold 3. So you get a Roman numeral when you have more than one possible charge. Zinc and silver don't get it because they have a fixed charge. Okay. Now, do you have to memorize these? Do you have to memorize the transition metals? Not really. Yeah, you didn't expect that, huh? If you're smart about it, which I know you are, then you don't really have to memorize them. And I will show you how to be smart about it. And I will show you how to extract it from a problem. Because every time I give you a transition metal, I have to mention which one it is, right? Otherwise you wouldn't know. So I will show you how to figure out their charges based on the problem given. So you don't really have to memorize this, but the two that you have to know zinc and silver because they have a fixed charge. So on exam, if you're doing a practice problem, you have a periodic table, label the periodic table. That's easy to do. Label the periodic table and then know that zinc and silver are +2 and +1. And the rest you can figure out. So far, so good? All right. So now what we should do, let's do practice problems. That's the best way to do this. Let's do practice problems. Now, these are, I'm going to give you 5 ionic compounds. They're already balanced. Now, what I want you to do, I want you to name them. So they're already balanced. What I want you to do, I want you to name them. So pause me, name this, and then let's go over it together. AuBr3, again, ionic compound because you have a metal and you have a non-metal. You have a metal and you have a non-metal together. That's the ionic compound. Is a balance of charges, but the charges have already been balanced. That was our lecture last time. So what is Au? Au is gold. What is Br? Br is, let me write a little bit more bold. So Au is gold. Hopefully you memorize that. And Br is bromine. But we said when we naming them, the ending changes to "ide." So gold bromide. Okay. So kind of review what we talked about last time. We said you name the first one as is. You name the second one. And you change the ending for the second one for the non-metal to "ide." Gold bromide. Now here's the problem. If I tell you, can you write the formula for gold bromide, you won't be able to do it. You're going to ask me, well, which gold are you talking about? So you have to mention which gold. All the elements that have more than one possible charge, you should always mention what that charge is. And all the transition metals, except zinc and silver, are going to have more than one possible charge, so you have to mention that charge. Okay, I'm going to go back over here again. So here is all the transition metal. All the transition metal, with the exception of silver and zinc, have more than one possible charge. So every time you have a transition metal, you have to mention which one you're talking about. Now, I told you don't really have to memorize it. Here's how you would figure it out. You know that bromide has a -1 charge, right? You know that because Br is right here. Halogens, they have a -1 charge when they form a compound. Now, where did the 3 come from? The 3 come from gold because you cross-multiply the charges. So when we cross-multiply the charges, we don't write the 1, so the 3 had to come from gold. So which gold we're talking about here? In this case, we're talking about gold 3. We're talking about gold 3 bromide. So far, so good. Okay, let's do the next one. CuCl. Again, all of these are already balanced. I just want you to name them. Cu is what? Cu is copper. Hopefully you memorize the name. Now, is copper a transition metal? Yes. Copper is a transition metal. Look at your periodic table. And is not zinc or silver, so that means it has more than one possible charge. So I have to mention which charge does copper have. Now Cl is chlorine, so the ending changed to chloride. But I have to mention which copper it is. Now I know Cl has a -1 charge, right? Is in a halogen group. Now, if that one has a -1 charge, the copper has to also be +1 charge, right? Because this thing is balanced out. There are no subscription here. Okay, so copper, which copper do I have? I have copper 1. It has to be copper 1. So you see how I didn't need to memorize all the charges for transition metal. I can figure it out based on the problem. So far, so good. All right, next one. Cs is cesium. Okay, I have cesium. And what is P? P is phosphorus. but it would become phosphide. Cesium phosphide. Cesium phosphide. Now, cesium is right here, has a +4 charge. Phosphorus is here, -1 charge. They only have one possible charge. They're not a transition metal, so I don't have to write down any Roman numeral. Roman numeral are only for the ones that have more than one possible charge. So this is cesium phosphide, and this is already balanced out. Okay, next one, Mni4. So what do you think? What is Mn? Mn is manganese. Mn is manganese. Make sure you have memorized the name of element. Is manganese. Now what is I? Iodine, but the ending will change to ide, iodide. Manganese iodide. Okay. Now, iodine is right here. Now, where is manganese? Where is manganese? If I look at the periodic table for manganese, where do you see manganese? Is manganese a transition metal? Yes. Manganese is right here, is a transition metal. So, it's not zinc or silver, which means it has more than one possible charge. Now, based on this, what's the charge of manganese? I know iodine is in a halogen group, is -1. Now, where did the 4 came from? The 4 came from manganese. So, which manganese are we talking about? We're talking about manganese 4. We're talking about manganese 4. So, what does that mean? What that means is I did not need, again, to memorize these things, right? I could figure it out based on the problem. You guys feeling good about this? All right. Ready for last one? Last one is the hardest one, but I think you can do this. All right. SNS2. What do you think? What is the name for SNS2? This is as hard as a naming for ionic compound can get. So if you don't get it right, don't be discouraged. So probably you said SN is 10. Okay? And S is sulfur. So if I change the ending, it becomes sulfide. 10 sulfide. Raise your hand if you got 10 sulfide. Okay. You're almost there. Except what you have to remember is that 10 and lead are the only ones, minus the transition metals, that have 2 possible charges, +2 and +4. So you can't just tell me 10 sulfide, because if you ask me 10 sulfide, I'm going to ask you, well, which one? Is it 10-2 or is it 10-4? Now, here's probably what you did. You go, so I know the 2 has to be from 10. So this is 10-2 sulfide. Almost. This is a tricky one. Here's why that's not right. So I have SN and I have sulfur. Yeah? Stay with me. You know sulfur has a -2 charge based on the periodic table, right? It has a -2 charge based on the periodic table. That doesn't change. It has a fixed charge. But I know 10 could be +2 or 10 could be +4. So I'm going to go back here again. So I know sulfur has a -2 charge, is fixed. But I know 10 could be +2 or it could be +4. You guys are good so far? Okay. So over here, remember, what we do, we cross multiply the charges. If I do that, what I end up getting, I'm going to end up getting SN2, S2. But remember what we talked about. After you cross multiply the charges, if you could simplify, you must simplify. Can I simplify here? Oh yeah. What can I simplify by? I can divide it by 2. So it would be SNS. So I simplified by dividing it by 2. And you must simplify when you can. Okay? Now let's come over here. Hopefully you see where I'm going with that. I'm going to cross multiply the charges. If I cross multiply the charges, I get SN2S4. Can I simplify? Yes, I can simplify, and because I have 2 and 4, and if you can simplify, you must simplify. I simplify by dividing it by 2, so I get SNS2. So what's the right answer? Which 10 do I have here? I have 10-4. I have 10-4. So I have 10-4 sulfide. This is, again, like I said, this is as hard as a naming can get. So whenever you have 10 and lead, be very careful, because 10 and lead could be +2 and +4, and sometimes +2 and +4 are very easy to simplify, right? So be careful about that. So far, so good. All right, beautiful. Now, I want you to take out the handout on a transition metals one more time. So, as I showed you right now, again, you don't have to memorize this. I have to tell you somehow. All the transition metal have a Roman numeral because they have more than one possible charge. So you have to tell me which one you're talking about. And the only ones that don't get a Roman numeral are zinc and silver. Because when you tell me zinc ion, I know zinc is +2. When you tell me silver, I know it's Ag +1, because that's the only possible charge they have. But when you tell me gold, I was like, well, which one? 1 or 3? So you have to have a Roman numeral. Now, there's one more thing I want to point out for transition metal before we move on. And that is mercury. Find mercury for me. Mercury is right here, right? This is mercury. Now, if you look at mercury, mercury is a little interesting. Let's look at mercury 2. So the symbol for mercury is Hg. Okay. Mercury 2 has a +2 charge. So mercury 2 has a +2 charge. That makes sense. This is mercury 2. Now, look at mercury 1. It also has a +2 charge. And it also has a bracket. What's going on? Here, what's going on? Mercury 1 gets lonely and doesn't want to be by itself. So it always hangs out with another mercury 1. So mercury 1 does not want to be by itself. It's always hanging out with another mercury 1. So you always have 2 mercury 1 hanging out together. Because you have 2 mercury 1 hanging out together, the way they write it, they put it in a bracket and they write Hg2. Now, because you have 2 mercury 1 hanging out together, the overall charge is going to be +2 because you have 2 mercury 1. You add it up together, the overall charge ends up being +2. Now, this is mercury 1. So mercury 2 is easy, has a +2 charge, mercury 2. Mercury 1, it will always be 2 of them hanging out together. Always be 2 of them hanging out together. So, because 2 of them hanging out together, the overall charge is always going to be +2. And that's why they always put a bracket around mercury 1 and they write Hg2 because 2 mercury 1 hanging out together and the overall charge will be +2. All right, so far so good. Beautiful. Now, let's go over the next part. So, we've done ionic compound with a periodic table. Now, the last thing to do, we're not done with the ionic compound yet. Take out this sheet for me. I emailed you guys ionic polyatomic ion. Take out the polyatomic ion sheet for me. Okay, so what we're going to talk about, we're going to talk about ionic compounds with polyatomic ions. Ionic compounds with polyatomic ions. Now, here's the thing. So far, everything we've done simple ions. So far, everything we've done, there are simple ions. What do I mean by that? So I say sodium ion. If I say sodium ion, you know is Na+1, right? That's one ion, sodium ion. Chloride is Cl-, is one ion. But these are simple ions. So what that means is you just take the ions, the atoms from the periodic table, and you give it a charge, right? You take it from the periodic table. Let's go back to the first page. You take all these atoms from the periodic table and you give it a charge. Those are simple ions. Okay. Now we're going to talk about polyatomic ions. What are polyatomic ions? Here, polyatomic ions, they're non-metals bonded together with one overall charge. Non-metals bonded together with one overall charge. Now, the idea is crazy, but it's okay if you're confused. I'll take that. We're going to do so many practice problems that you're going to get comfortable. So, I want to give you an example of polyatomic ion. So, polyatomic ion. So, simple ions, you know. You take it from the periodic table and you give it a charge. For example, before I do that, so sodium and Cl were the ions. NO3 minus 1. Now, NO3 minus 1 is one ion. That's what is so crazy about them. It's not nitrogen and 3 oxygen. No, this is one ion. What we call this is called nitrate. Is one ion. So polyatomic ion, when you have a bunch of non-metals bonded together with one overall charge. The overall charge is -1. But this is one ion. And that's the concept that is crazy a little bit. Well, that's chemistry, right? But it's fun. SO4 minus 2. This is one ion. SO4 minus 2. This is one ion. It's crazy. It's one ion. What we call this sulfate. Okay? Is one ion. So, here are the polyatomic ions. Here are the polyatomic ions. Okay? Here are the polyatomic ions. Now, what I'm hoping you would do today in this lecture and this week, if you see a polyatomic ion, you go, okay, that's a polyatomic ion. I know that's a polyatomic ion. So be able to recognize polyatomic ions. That's all I'm asking you guys to do right now. Be able to recognize polyatomic ion. Okay, these are all the polyatomic ion. One ion with one overall charge. Now, there's a couple of them I want to pay attention to. And this is the best way I could organize it for you. Let's go over here. Nitrate is NO3 minus. So nitrate is NO3 minus. Nitrite is NO2 minus. So when you have one less oxygen, what happens is 8 becomes 8. That's one way to think about this. So here I have sulfate. Sulfate is SO4 minus 2. Without looking at this, don't look at this. What do you think sulfite would be? SO3 minus 2. So 8 and 8 for the same compound. Basically, when we have one less oxygen, 8 becomes 8. We see the same thing down here. I have phosphate. Phosphate is PO4 minus 3. Without looking at it, don't cheat. What do you think phosphite is? PO3 minus 3. Okay, so again, 8 becomes ite when you have one less oxygen. Minus that, there's no other pattern going on. These are all the polyatomic ion. You just gotta memorize them, and you gotta know them. I have a student who told me that the way he memorized this was that he was putting all these polyatomic ions on a beer bottle, and as he was drinking, he was memorizing the polyatomic ion, but he failed the class. So I do not recommend that. Flashcards, there are apps for this, so you would have to memorize these polyatomic ions. Now, if you're in Chem 30A, you do not have to memorize them, but if you're in Chem 1A, you would have to know these polyatomic ions. I know that they seem crazy, but we're going to use them so much, and you will get them down. You will get them down. All right, so now that you know what these polyatomic ions are, and all I'm asking you this week, just when you see a polyatomic ion, go, that's a polyatomic ion. I know that guy, okay? That's all I'm asking you. Now, let's talk about writing and naming ionic compound with polyatomic ion. Writing and naming ionic compounds with polyatomic ions, because you know how to write simple ions and how to name them, but let's go over polyatomic ion ones. Let's do this. So I want to put together Na and SO4. So when you see Na, the first thing we go, okay, I know Na. I want to look at the periodic table. Take out your periodic table again. I go, sodium is right here, group 1A. So the sodium has a +1 charge. And then I'm hoping you look at SO4 and you go, this is not sulfur and oxygen. No, this is a polyatomic ion. Then you're going to look at your polyatomic ion sheet. Which polyatomic ion is that? That is sulfate. So that's what I'm hoping, that you see a polyatomic ion and you're going to be able to recognize it. You go, oh, this is a polyatomic ion. It's sulfate. The charge is -2. The same as before. You're going to cross multiply the charges. You're going, watch my pointer, you're going to cross multiply the charges. That hasn't changed. If I do that, I get Na2SO4 because we do not write the 1. Okay. So I just balance a polyatomic ion. The same way we're balancing the simple ions. Now, what we want to do, we want to name them. How would we name this? Naming is a little bit different. So Na is sodium and SO4 is sulfate. So sodium sulfate. Now, how come I didn't change the ending to "ide"? Now, here's why. So before with the simple ions, you used to change the naming to "ide" because the ending will tell you what you have. Remember, sulfate is SO4, sulfite is SO3. If I change both to "ide", then I don't know which one I have. So the ending for the polyatomic ions actually are really, really important because they tell me which polyatomic ion I'm talking about. So do not change the ending. You name him as is. You name him as is. We're good? Okay. Now, do this. Let's put the next one together. Al and CO3. I want you to put this together. Al and CO3. Put this together for me right now. Okay. Now, aluminum. I want to find aluminum on the periodic table. Is right here. The charge is +3. So aluminum has a +3 charge. And I'm hoping you go, oh, CO3. That is a polyatomic ion, right? I'm going to go to my polyatomic ion chart. Again, you can have this in front of you right now. What is CO3? CO3 is carbonate. CO3 -2 is carbonate. So have this chart in front of you all the time. So this is carbonate with a -2 charge. Okay. Now what am I going to do? What I'm going to do, I'm going to cross multiply the charges. I'm going to cross multiply the charges. The same thing as before. So Al is going to get a 2 and CO3 is going to get a 3. Again, the same thing as before. I'm going to cross multiply the charges. Now, look over there. This is weird, isn't it? Like, what is that? So, because CO3 already has a number, and you want to bring another number next to it, this looks really weird. So, to avoid this, what we do, we put a parenthesis around it. So, what that means is, I cross multiply the charges, and I have 3 carbonate. Alright? Now, how would you name this? How would you name this? You would name this aluminum, and CO3 is carbonate. Aluminum carbonate. And you do not change the ending. And you do not change the ending. We're good so far? Okay. Now, you want to do a couple more practice problem? Yes, let's do a couple more practice problem. Here are our 2 practice problems. The first one, I want you to name it. It's already been balanced. The second one, I want you to write the formula. Okay, you have the periodic table in front of you. You have the polyatomic ion chart in front of you. Okay, let's do this. So hopefully you pause me, unpause me. Fe. What is Fe? Fe is, what just happened? Fe is iron. Okay. What is PO4? I'm hoping you say, oh, PO4, that must be a polyatomic ion, right? So I'm going to go back to my polyatomic ion sheet to see if I can find PO4. PO4 is right here. It's a phosphate. What's the charge on it? -3. So I'm going to come over here. So they say this is iron phosphate. Because when we have ionic compound with polyatomic ion, we don't change the ending. Iron phosphate. Almost. Where is iron on a periodic table? Iron is right here. It's a transition metal. So if I have a transition metal, that means it has more than one possible charge. That means you have to tell me which iron it is. Now remember, we looked over here. We said phosphate had a -3 charge, right? So if phosphate will always have a -3 charge, what does the charge on iron has to be? It has to be +3, doesn't it? Because they end up canceling each other out, and I have nothing down here. So there has to end up, I know this is -3, and I know there's nothing down here, so this one has to be +3, so they would cancel each other out. So this is iron 3 phosphate. Okay. Now, next one, I want you to write the formula. Lead 4 chloride. Now, the key to this one, you go, this is ite. If I have ite, that's probably a polyatomic ion, right? All the 8 and ite are polyatomic ion. So, chloride. I'm going to come over here to see if I can find chloride. Chloride is over here, is ClO2 -1. Is ClO2 -1. Okay. Now, lead 4. I know that lead is Pb. So, and chloride, I went over there, chloride was ClO2. Was ClO2. And I is telling me that is lead 4. So, it's +4. Because lead and tin, you have to tell me what it is. And if you look at a polyatomic ion sheet, chloride is -1. Again, if you are taking Chem 30A, you do not have to memorize a polyatomic ion sheet. I will give it to you. All right. Now what do? We're going to cross multiply the charges like we've done before. Nothing fancy at all. We're going to cross multiply the charges. We've done this before. If I do that, I get PB1. We don't write the 1. and then ClO2, 4. And I have to put a parenthesis, so there is a, so these two numbers are not going to be mixed together. That means I have Pb, 1 Pb, and 4 ClO2. So this is lead 4 chloride. This was a big lecture today. And we're going to keep going with naming. And I'm going to have a lecture, have a class that I do nothing but practice problem. Just remember, let's summarize this together. You have a periodic table. As soon as you see a periodic table, label this. +1, +2, +3, -1, -2, -3. Less than 10, +2 or +4. Okay? So these are simple ions. Transition metal, they're a mess. They have many, many possible charges. Except zinc will always be +2 and silver will always be +1. The rest, they have different charges. They have many different charges. So I would always have to give you somehow what those charges are. So they get a Roman numeral. Tin and lead also get Roman numeral because I have to tell you which one I'm talking about. Then the new thing we talked about today was polyatomic ion. These are polyatomic ion. That's how they exist in nature. Don't ask me why. Probably because of stability. They're more stable this way. And all I'm asking you, when you see one, go, oh, I know what that is. That's a polyatomic ion. So you have this sheet in front of you as you do in practice problem. All the polyatomic ion except ammonium are negatively charged. So far, so good. Okay. Beautiful. Now, the next thing I want to talk about before I let you guys go, this is fun. Why do you have to, one thing that people always ask me is like, why? Why do we have to know this polyatomic ion? Life was good until we got to this point. I'm usually popular and then I show the polyatomic ion and then I'm not popular anymore. So let's go over why you have to know the polyatomic ion. Do you guys read labels on things like shampoo, soap, food? Do me a favor. Today, right now, pause this video. Go grab a shampoo. Go grab a lotion. Go grab soap, food, anything that has label and has ingredients. Read the ingredients. I promise you, one of these polyatomic ions is going to be in that ingredient. So it's kind of cool. Now you know stuff now. You know you can brag about it to your parents, so they know your tuition is well paid. Now let's do one fun thing, and then I'll let you go. One fun thing will be fun. I don't know if you've noticed this. If you haven't, your parents probably have, and hopefully you will notice it too. When you go to Trader Joe's, for example, or Sprouts, or Safeway, wherever you go to shop, when you're going to go buy lunch meat, there is usually a section, Whole Food has a huge section on it, that you can buy lunch meat that on the label it says no nitrate or nitrite added. And then it's over here, no nitrate or nitrite added. Applegate, you can find this at Whole Food, no nitrate or nitrite added. So when you go to buy lunch meat, you have options. You can buy lunch meat that has nitrates and nitrites, or you can buy lunch meats that have no nitrates or nitrites added. And usually these ones are a couple dollars more expensive. Now why is that? Why are they charging you more for things that have no nitrates or nitrite added, and they're advertising it on the label? So if you Google this, you will find an article that says nitrites and nitrates are carcinogen and they can cause cancer. Here's one thing to also keep in mind. I feel like nowadays, every morning I read the news, there is a new item that is going to cause cancer. The other day, I was reading the news. It was like, oh, popcorn. Don't eat popcorn. It's going to cause cancer. I was like, no, not popcorn. I like popcorn. So you have to be very careful with a lot of information out there. So what about this one? You see this all over the place. If you go to a grocery store next time, go to the lunch meat section, you'll see there's so many of these that says no nitrates added. They advertise it and they charge you more. Should you pay a couple dollars more to buy the ones that don't have nitrates and nitrites added? First of all, this is really cool about the thing is that you know what a nitrate is. And you know what a nitrite is, right? They're polyatomic ion. So you're way ahead of the rest of the country because you know what these things are. Nitrate and nitrite. You know what they are, right? NO3 minus 1, NO2 minus 1. That's pretty cool. So this is one of the cases that I do believe that avoiding nitrate and nitrite is a good idea. Why is that? So nitrate is NO3 minus 1. Nitrite is NO2 minus 1. Nitrate and nitrite, they have a lot of oxygen. Oxygen has a lot of electron. Now, your DNA loves electron. Your DNA is desperate for electron. Oxygen has electron. Your DNA wants electron. So what they can do over time, again, not just if you eat it once in a while, if you accumulate over time a lot of these can go and bind to your DNA because DNA wants electron, these guys have electrons. They can go and bind to your DNA. And when things bind to your DNA, that's where things get really, really scary, right? And that's when cancer happens, when things bind to your DNA and you cannot reverse it. So this is one of the cases that, it might not be a bad idea to consume things that if you can avoid it, why not avoid it? Again, you have to consume these for a long time, a huge amount over time to go and bind to your DNA and have an effect on it. But if you can avoid it, why not avoid it? So this is, you can go and brag about this now. Now you know stuff. So this is why you have to care about polyatomic ions because they're everywhere. You'll see them. We'll talk about them. I'll bring a fun item every time to show you a polyatomic ion. Nitrate and nitrite was for our today's lecture. Very nice job. We're going to keep going with naming, and don't worry, we're going to do a lot of practice problems to make sure that you get these down. I will talk to you guys next time.